Okay, with sine law, one of the criteria in order to use it is you need it to have a side and an angle across from it. Okay, so what happens if we don't have the side and an angle across from it? Because we can't use the sine law, so we're going to use it with the law of cosines. Okay, so an example. A question in which we would need the law of cosine. Actually, I'm going to draw this a little bit better here. What to do? Okay, so this angle here would be 155 degrees. So it's not quite look like 155. And we have 100 here and 50 here. So A, B, and C. All right? So starting with side A. Okay, because we don't have an angle on the side across from it, we need to actually solve using the law of cosines. And the law of cosines says this. A squared is equal to B squared plus C squared minus 2BC times the cos of the angle. So in this case is A. Now, I don't mind putting that down as our base equation, but we don't always use A, B, and C triangles, and we don't always use the angle that we're looking for, or the side that we're looking for as angle A. So here's what I'm thinking that I want to do with it. I'm going to take the side that I don't know. Okay, and then I'm going to use the other two sides. So 100 squared plus 50 squared minus 2 times 100 times 50 times the cos of the angle that I know, which is 155. A equals. So I can put this right into my calculator as it is, as it looks right here. So I go square root, it's going to open a bracket for us, using the TI-83. 100 squared plus 50 squared minus 2 times 100 times 50 times cos 155, and you'll need to close the brackets twice. Okay, so take your calculator out right now and let's work through this. Okay? Again, this is in your workbook, so you can actually fill this in as you want, if you wanted to in your workbook. Somebody have a solution for me? What's side A equal? 0.844. Okay, and again, I go back to this as we did before. You want to use at least 3 decimal places. Because if I ask you now to find angle B or angle C, you need to use that side in order to get it. All right? So, sine angle B over 50 is equal to the sine of 155 over 146.844. So angle B is equal to. So now I use the law of sines. Once I have a side and an angle across from each other, then I can use it to find the other two ratios. So punch that into your calculator. So 50, or the second function sine of 50 times the sine of 155 divided by 146.844. And what do we get as angle B? Very good. 8.274 degrees. Thank you. And then angle C. So how does this switch my ratio? Instead of sine B over 50, I'm going to use sine C over 100. Right? Across from it, 100. So sine C over 100 equals that. What do I get for my angle? So you have 100 times sine 155 divided by 146.844, second function sine. 16.726 degrees. Now I would add these two together with 155 and I should end up with 180. So again, you can always guarantee that you have it right. And if you don't, you can find out what's wrong and then change it. So before you finish your test, you should be able to check and make sure you have it right. Okay? Now this is the easy part. Not that there's a real hard part, but this is the easy part. Because I don't have to do anything. I just have to put them into that equation and then punch it into my calculator exactly as it looks. The difficult part is if I have to find an angle using that equation. All right? But again, once you see the pattern, it's actually pretty simple. So, any questions about this? Okay, again, all of you have done it in applied math, so it's not new to you. Okay? So, again, you can follow through and write this out in your workbook if you want. I'm not going to put it on separate paper, but whatever. Okay, so let's find, I want to find angle A to begin with. So there's what I have right now. Same thing, right? Now we need to isolate, because I want to find the angle A, so I need to isolate this. So what's the first thing that I'm going to do to isolate this whole thing right here? I need to get rid of b squared and c squared. How do I do that? Subtract them. So I get a squared minus b squared minus c squared equals minus 2bc cos A. So now how do I isolate cos A?
Minus b, c,
Divide.
a squared minus b minus
C squared.
b squared minus c squared over minus 2bc.
That's right. Okay? So I'm dividing both sides by that right there. Okay? So I have cos A equals. Now, here's the thing. Two things that you need to remember. You need brackets top and bottom. Absolutely necessary. The starting letter right here, or the starting number that you're going to use, is going to be the one that's across from that. Okay, so that's what you have to remember. If you have that, you can't get it wrong ever. Alright? And then I go minus b squared minus c squared over minus 2bc. So in this question here, I have the cos of A is equal to, what's the side across from angle A? 20. So it's 20 squared minus 14 squared minus 15 squared divided by minus 2 times 14 times 15 equals. Okay? Again, obviously, if you're looking for the angle, you need to use second function cos. So what I want you to do is go second function cos, open two brackets. So it'll automatically open one. You open a second bracket for this top part, close it here, then divide, then open a bracket on the bottom, and you'll have two brackets on the end. Okay, so somebody give me the angle A. .866.
I got
That seems a little low.
87.134.
Okay, so let's check that again. Try one more time, Shayla, and then we'll go back. I want to see. So, are you putting second function cos to begin with?
What did you get?
Okay.
87. That's what
What'd you get, Nicole?
87.134.
Everybody should be trying this right now so that I know whether or not you're doing your calculator right. You got it now? Okay, excellent. Anybody not get it? You need a bracket on the bottom here.
Oh, I put it. Okay, yeah.
Okay, anybody else not get that solution yet? We're okay?
Oh, well, don't do that.
All right, I want you to try this one more time. B now. Find me B. Now, normally we could go right to the law of sines here, but we're not going to. We're going to keep it consistent. We'll stay with the values that we know, which is these ones. So what's the first number that's got to go on top here then? 14 squared. That's right. So push that into your calculator and see what we get. So it'll be 14 squared minus 20 squared minus 15 squared over minus 2 times 15 times 20. Okay. All right, let's do C then. Jaden, you getting this? Okay. Let's do C, and then we'll add it up to see if we got it right. $48 decimal. Beauty. 509. Okay, add those three numbers together and we should be close to 180. It is 180? Awesome. It's not tough, is it? Okay, so where is it going to get tough? Where is it going to be difficult for us? Well, the long and short of it is, the only way it can make it difficult is to give you word problems and you got to draw your own triangle. The only place that it's going to cause you grief. Other than that, you won't have a problem with these questions. The equations are pretty foolproof. Okay? Anything from cosine law needed? All right, how about Friday's work or Thursday's work on the law of sines? Any questions on the law of sines?
I was stuck on C.
Okay. Page 89, letter C, 4C. Okay, so draw it out first. We have 36 degrees. We have M right here, 2.95, 3.75. And the question says to us, calculate the altitude or the height in the triangle. All right, so I'm looking for this right here. All right, let's take the pieces of the triangle that we do know and let's use it, right? Because if I draw it out with just the height and I ignore the one line of LM, this is still 36 degrees here, right? This is still 3.75 here, correct? And that's a right angle. I don't need the other angle though. Got a right angle triangle.
Yeah.
Okay? All right, now, the question should have asked you for this guy,
Yeah, that's what I was thinking I should have got to.
but it didn't. It just asked you for the height, so all I do is I created that triangle. Other questions from Thursday's work? No? Yeah? Page 90, 5C. It says determine how many triangles satisfy this. All right. Okay, so how many triangles are there here? For me? How can you tell?
Because our copies of the things other than your side,
Where's the right angle?
there's,
So there's no hypotenuse.
some
So why does this not work? What kind of triangle did I draw here?
not
Not a right angle one. We know that, right? But what kind of triangle is it?
obtuse.
It is an obtuse triangle because of the angle being greater than 90, correct? Well, what else do I know? What's it called when you have two sides that are the same in a triangle? It's an isosceles triangle, correct? So if this is 10 and this is 10, then the two angles across from them have to be what? The same. Can that be 116 and this be 116? No, it can't. There's no triangle there, right? There's your solution. All right?
Doctor's appointment. Doctor's appointment,
All right. Any other questions?